In this lecture, we are going to study about the machine learning life cycle. So, ML follows some steps. What are these steps? There are certain major steps which has been followed to use your machine learning technique, starting from data gathering. Okay, that means you need to collect the data from various sources, or I would say you need to collect the data from relevant sources. Then you need to perform operation over the data, because ultimately we need to work on data itself. So here all the technologies which are now right now present, whether it is a data science or data analyst or machine learning or deep learning, okay, everything depends upon the data. And I already told you that it's a data driven technology, data driven. Okay, so you need to collect the data, then you need to prepare the data for its to get used, to make it purposeful. Okay, so data should have to be prepared, because obviously when you gather the data, when you collect the data, that is in a raw format. It's not in a that particular format that should have to be used further. So you need to prepare the data, you need to organize the data. Okay, then the next thing is your data wrangling or data cleaning. Okay, your data might be comprises of the faulty values, it might be comprising of the null values. Okay, so you need to clean your data. Okay, after cleaning of the data, we need to perform the analysis over the data, that is exploratory data analysis we need to do. Okay, then after EDA, we can also have the visualization of the data. Okay, so we can compare various features which are available in the data, and prepare the plots for them. Then we need to select our model and train our model, okay, with this data. Okay, whatever the task you are available within machine learning, either you need to perform the prediction or classification or whatsoever you want to do, you need to select your model, you need to fit the data into your model, and you need to train your model according to the training data. Then you need to test your model, whether what is the accuracy it's been coming, what accuracy it has been giving to me. So you need to test your model with the data, and then you need to finally deploy your data. So this will be like an end to end project, and this is what the steps I also used to follow. You also follow the same technique, same approach, okay, to prepare a machine learning project. On every weekend we used to do the project. If we are having a topic of ML, so these are the same steps we do follow. Okay, so if I talk about your gathering of the data, as I told, that data can be collected from various sources, either from it can be various files from various database, internet, mobile devices, or anything, any of the source which has been able to capturing the data. You can collect the data from that. Okay, and this data, the quality of the data will define the efficiency of the output, what features you have considered here. Okay, and what is the quality, whether your data has been valid, relevant, effective or not. Okay, so the quality of data determines what output you will be getting. The next thing is what steps you are going to follow. So you need to identify what the sources are available for the data collection. Okay, from where I can collect the data, what are the sources. First identify the sources, then collect the data from them, then integrate the data obtained from the various sources. Okay, because if for example I have decided some topic to be performed. Okay, so this Sunday for example we are having a project on Zomato. Okay, Zomato rating for the restaurants. So I need to collect the data for the Zomato restaurant ratings. For every restaurant, I need to have the data, what rating they are having. Okay, so either I go to the website and scrap the data from the website, or either if it has been already available at some of the sources on the internet, I do collect that particular data set from it. Or rather I just go visit to some or rather I check some app related to the Zomato and check what are the ratings are. So there are various sources, and finally I'm going to integrate them. Okay, so this is how you can collect the data. Now next is you need to prepare your data. Okay, so after collection you need to prepare, and there are certain steps. Data exploration. Okay, that means it is used to understand the nature of the data. what you have to work. So every time, you very well know that when I get started with the project, I first explain you the data set. Okay, I tell you, okay, this is the data set, these are the number of features, these are the columns which we are available with. The column number 1 is this, column number 2 meaning is this, column number 3 meaning is this. So you need to understand what features you are available in the data, whether we want to keep them, whether we want to not keep them, what is the characters, what is the quality. I always tell you, okay, this column is looking like it is having a numerical value, this column it is having some categorical values, this is having text. So we just understand the data. Ultimately, data exploration is exploring something, understanding, okay, what we have, what we have collected. Okay, after organized data, what we have collected, and then we perform the pre-processing. Okay, that means pre-processing is the other. Now, and after understanding, we can pre-process. That means for analysis purpose. Okay, so it is a next step is the pre-processing of the data for its analysis. What should be I keep, what I should not keep, what modification, what changes has been required, or whatever the things which we did observed by understanding the data. This will all comes under the pre-processing. The next thing is your data wrangling. See, it is a process of cleaning and converting raw data into usable format. Okay, because we can't use the raw data directly, because it may be either structured or unstructured, whatever the kind of the data which we have collected from the sources. Okay, so we need to check out that whether we can use it or not. So data cleaning, converting the raw into some information. Ultimately, I need to make it as an informative data. So for that purpose, I need to check the missing values. Okay, is there any cells which are not having any value or null values, whether we are having a duplicated data, whether we are having an invalid data, or whether we are having a corrupted data or the noise. So every time when you see how I do approach my ML project, first thing is I do import the libraries. Okay, then I access my CSV file, then I print the head, then I print the tail, first five and the last five. So this is what I'm exploring my data. Okay, what I have access, I let me explore it. After exploring of my data, then I print the shape. Okay, what is the shape of my data set, how many rows and columns I am having. Then I do print the column names in my data set. Okay, then I do check for the duplicates data. Okay, then duplicated dot sum, I apply this technique. So this is what happens in your data wrangling, only data cleaning. Okay, so I do check for the duplicates. If I found any duplicate, okay, then I remove the duplicates, drop underscore duplicates, I use this method. Next thing is I also check for the null values, data dot is null dot sum. I do perform the same thing, only missing values I need to find, null values are there. If there are null values, then you need to take a step. What step you need to take? If any of the column which is having many null values, for example, so whether that particular feature is important or required to keep in our analysis. So we need to take some step, either replace the null values with mean, median, mode, whatsoever, if it is in a numerical format. Okay, else you need to take some other steps for that. Okay, if that particular feature is not important, so and it is having mixing values, then you can drop that particular column also, no need to keep it. Okay, so various steps you used to take while finding if there is any missing values or null value, because we can't work with the missing values, though we can work with the duplicated data, no worries, but we can't work with the missing values. Okay, it will definitely give you error ahead when you put this kind of data into your modeling. Okay, invalid data, that means the data which is having some wrongly fed data. Okay, and you do perform your outlier detection. Okay, for the purpose outliers, that means those data which are being wrongly fed into while preparing your data set, and you got the result, that means which may put a change. Okay, which can have a deviation in your analysis. Okay, so invalid data, okay, wrong data. Noise, okay, noise is something, it's a corrupt again. uh, Invalid data, that means data which has not been valid, accuracy related. Noise is something wrong. Okay, noise is something corrupt, that is called as a noise. So I need to check out for the noise. I need to check about the validity of the data, whether it is valid or not, whether it is correct or not. Okay, so after performing all these operations, we say now our wrangling or cleaning has been over. After that, when your data is good, okay, after you have performed the analysis of analysis means in such a way that you have clean your data, then comes data analysis. Data analysis, here we are going to perform the use of analytical techniques, or we need to build the models, we need to review the results. Okay, now when your data is cleaned and your data has been prepared, it should be passed for the analytical steps, analysis. So the aim of this step is to analyze the data using various analytical techniques and the review outcomes. Okay, so what basically we do in exploratory data analysis, what basically we do in EDA. You know, you have attended most of the projects. What basically we do in exploratory data analysis, exploratory data analysis, what does this means, what we do?
We check for missing values, impute it, or
Hmm.
stuff like that. And we even plot it and see if
Hmm.
there's any correlation between the
Correlation, very
coefficients.
good, very good.
with the different graph plots, like
Yeah,
we are analyzing the
actually we are
relation between
see,
points.
we are available with now a clean data, and we are having all the features. Now in case of EDA, we need to look out for what features are important and relevant for us to use in the model further. Secondly, as you told that sir, we used to plot the graph. Okay, we used to find the relationship between the various parameters and the features, we show them in the form of a graph. Okay, and then after doing all these things, then we build the models. Here the model building is also there. Okay, we build the models, we select what is our according to our problem statement, we need to use what model has been required here. Okay, so building will be there. Okay, and then, and after plotting these all graphs and doing all this analysis, we review also. Okay, and review means we check out, okay, this parameter is having this kind of correlation with this parameter, so here we also print the correlation matrix, we also draw the heat map. After heat map, we use our model. Okay, after finding the correlation, we use our model. Okay, we what is the problem statement accordingly, whether it's a regression, so we use linear regression. If it is a classification problem, we use logistic regression or decision tree or random forest, whatever we are going to use. So after your data has been perfect, okay, we explore, we do the count plot. Okay, for categorical data, we draw a scatter plot, we draw bar plot. Okay, we can draw the pair plot, various kinds of plots we can draw. Okay, and we find the relationship, correlationship between the variables. Okay, and we also prepare our model which has been required. So here classification, regression, cluster, association, depending upon what kind of problem statement you're having, whether you're performing supervised learning or unsupervised learning, whatever you're going to do, accordingly we are going to apply the technique. In the next step, what we are going to have is your once your model has been available, then you need to train your model. Okay, training your model means you need to fit, because here you need to split your data into training and the testing. Okay, as you very well know that how to split your data, there is a library which we include in our project, that is train test split. Okay, so split your data into training and the testing, so 80% training data, then 20% your testing data. This is something which we always keep in our analysis. Okay, and then put your data into training purpose, your model will get trained accordingly. What happens actually in a training, so this is something very much important. See, what are your machine learning models are. See, your machine learning models are basically the mathematical equations. These are all maths. Okay, there is a complete math behind these models, by which they are being prepared. Okay, so what we are ultimately doing, we are putting our data, data, or I would say the features or the parameters into those equations, and we are getting the results. Okay, so you just put all all your values inside it, and we are ultimately here understanding the patterns, rules, and the features what the data you are available with. Okay, so we are putting all of them in these models or your mathematical equations, whether you are taking a linear regression, whether you are taking any logistic regression, okay, whether decision tree or random, whatever you are taking, you are just using all the mathematical foundation only. Okay, and then we are going to check out the what the patterns and rules and features which are available in them. So this is how your model get trained. Okay, and once your model get trained, you can put your value in it to perform the predictions. Okay, you can put the same set of values, okay, and perform the testing for it. Okay, and then the last thing is your deployment. So in our projects also we have seen the deployment. We have done the deployment with the help of a streamlit library. Then we have also performed the deployment on Heroku. Okay, that means we tried to make our website live. Okay, so once your model has been there, once your model has been prepared, you can download your model. I've also told you about the pickle library. Okay, you have done a lot of projects with me. So pickle, and that is your model. Once it trained, it can be downloaded into some binary format, and then you can load your model to perform the predictions or classification, whatever it has been prepared for. Okay, so in case of deployment, either you can deploy your model on a local host, or either you can deploy your model on the web. Whatever you want to do, you can do it here. So these are the general steps, starting from collection of the data till the deployment of your model. Every project needs to be follow the same steps, and this is how we call it as end to end machine learning project. End to end. Okay, now this is just a life cycle of machine learning, but as I told, that models is something which are based upon the mathematical foundations. So here we need to get started with our maths. Okay, so I just take a break here. Here it is a break related to your ML concepts. As I told, in my this course we'll go parallel. That means I will prepare your mathematical foundations along with your Python programming implementation and your machine learning concepts also. We'll go parallel by parallel. Now we get start with our maths, and this is our topic as linear algebra. Okay, linear algebra. If we want to work with machine learning or deep learning, okay, whoever you want to work with, mathematical model is a base or foundation of all these techniques. Okay, and they get started with the linear algebra because it is a very important tool. Okay, so what does this algebra means? In our in our school we have done algebra. Okay, algebra we have performed. We are having variables x, y, and z, and we form the equations. It's a linear equation, a quadratic equation, cubic equations. We have drawn the graphs related to it. So a lot of algebra we have already done. So here, to be very specific, we need to follow linear algebra. Okay, linear. Okay, so what is this linear algebra is? It is a branch of math that allows us to define and perform operations on higher dimension coordinates and plane the interactions in a concise way. Higher dimensional coordinates. Okay, so what does this means, higher dimensional coordinates? As I am did told you about, that we have the data. Okay, so data is having some numerical value. Okay, then we need to feed that data into equations, mathematical equations, and these equations will be in a linear format. Okay, so linear algebra is an algebraic extension, undefined number of dimensions. Okay, you can have any kind of dimension of the data available, whether you are having a single dimensional data, whether you are having a multi-dimensional data, whatever the dimension of your data is, we can feed this data into your algebraic equation, linear algebraic equation, linear. Okay, not quadratic, not a cubic, linear equation. Okay, any number of dimensions of data, and you can perform your operation. Okay, so why I'm considering the linear? Because it is a continuous type of mathematics. It is continuous type of mathematics and is applicable to science and engineering both. That is why linear algebra has been considered here. Okay, so it is continuous in nature. If we talk about linear algebra, it is continuous in nature, and we can apply here this concepts of linear algebra to any of your science and engineering applications. Okay, for development of the model. Okay, and putting the data into, feeding the data into those variables. Okay, and just getting the results out of them, just solving those equations and getting the results. Okay, so before we proceed much more related to the linear algebra, let us study some properties which are used here. Okay, first property is our associative property, association. So if you are having a plus b plus c, that means first we need to use b plus c. Okay, that is also equal to a plus b plus c. That means we can add b plus c first, and that then we can add result to a. This is also the fine. And if we first add a and b and then add c to the result, this is also okay. So this is a binary operation plus, binary operation plus I'm going to perform. This is associative property. Okay, with respect to plus operation, plus. Okay, commutative property. Commutative property means a plus b equal to b plus a. This is commutative with respect to the binary operation plus. Okay, either if I would say, if you ask me, sir, you're taking plus here as an associative. If you take multiplications, or what will happen? No worries, it will also be the same. If I do write like this, a into b into c like this. Okay, this will be all same like a into b into c. The result will all same. So here, with respect to multiplication, your associative property is working. So with respect to plus, with respect to multiplication, or either I can take commutative also. A into b equal to b into is equal to b into a. This will also work. Okay. If I talk about the distributive property, distribution. So a into b plus c is equal to a into b plus b into c. Okay. If you just multiply a inside these two values, obviously it will be like distribution. Your operator is now distributed with b and c. Okay, so here star and plus, these are the multiplicative operators. And why I'm taking these properties? Because in linear algebra, as I told, we need to work with the dimension. Ultimately in linear algebra we are having dimension. So dimension of whom? What dimension? किसकी dimension की बात कर रहे हैं? Whose dimension I'm talking about? I'm talking about the data dimensionality. Data, your data may be represented either in a scalar format, either your data can be represented in a vector format, either your data can be represented in a matrix format, either your data can be represented in a tensor format. Okay, this could be the representation of your data, and I need to feed this data into your mathematical equations. And the good thing to feed your data into mathematical equation is to consider the linear algebra. Linear. Why? Because it is of a continuous type, continuous in nature. This is what I need to consider here. Okay, so let's get ahead with the type of your data. Okay, scalar. You very well know about, we have already studied in physics and maths, and very simple the thing is, scalar quantities. Scalar quantities are those quantities which are just having a numerical value. A single value has been present. Okay, or just a single element. Okay, for example, if I write 5, this is a scalar quantity. Okay, it has only magnitude but not direction. Okay, so just a single value is called as a scalar quantity. For example, 17 to 56, whatever you will say, you say it's a scalar quantity. Next, vector quantities. Vector quantities, those quantities which are having magnitude and direction. This is a very famous definition in physics. Those quantities which are having magnitude and direction, they are called as a vector quantities. Okay, so here I am available with a vector, and in the notation of ML, how you define a vector? See, a vector is just have one index which can be referred to a particular value, and which is ultimately, here a vector is a collection of elements. A vector in machine learning, or I would say here we are using linear algebra, so it is a collection of elements, it's not just a single element. So if I do represent collection, how I do represents the collection of element in Python? Obviously in array format. So here you can see that there's a list e1, e2, e3, e4. Here is a list. Okay, so I can represent my values in a form of a list, or rather I can represent my values in a form of a collection of elements. Okay, so it is a vector quantity. So here v is a vector, e1, e2, e3, e4 are its elements. Okay, and if I do say what is v2, if I access element v2, so v2 is e2. Okay, this element, sorry, it is e3. If I just say what is v0, so this is e1, v1, this is e2. Okay, this is called as an indexing. Okay, so vector has just one index, and it can refer to a particular value within a vector. Ultimately the definition of a vector is it's a collection of elements, or I would say it is an array. Okay, so it's an array format vector in case of your machine learning. Okay, it's an array, collection of elements. So here previously we are having just a single element, we called it as a scalar, and if we are having an array, we call it as a vector. Okay, now uh, scalar vector multiplication, for example, there are some operations if I need to perform over these vector entities. So how I am going to take, if I just want to multiply a scalar entity with a vector entity, for example, here is my vector e1, e2, e3. Okay, and I am having a scalar quantity that is 2, and if I need to multiply a scalar with a vector, so here this is how the multiplication can be done. 2 is a scalar, and it can be multiplied with each and every vector quantity. 2 is multiplied by a vector p with all the elements which are present in a vector. For example, if we are having x equal to 1 comma 2, this is what, this is an array. Okay, and this is actually a vector. Okay, if I need to multiply 4 with it, so the result will be 4 comma 8. This is the multiplication of a scalar with a vector. This is how we can perform. Okay, now a simple or I would say a general explanation of vector quantities. Now your next is your, we are moving ahead with our data dimensions. So here what is the dimension? If I talk about the scalar quantity, sir, there is no dimension, only zero. Here the dimension is zero because we are having a single element only. Okay, single element, so no dimension. What about the vector? Sir, we have taken one dimension, sir. Now you're representing the data in a form of an array. Okay, that means either you can arrange them in a row format, or either you can arrange in a column format. That means I got something, sir. Okay, that means you are here, if I just say e1, e2, these are elements are arranged in a row format, all the elements are row. Okay, one row, and four columns are here. And now if I just transform this thing like e1, then e2, then e3, then e4, then it will be like four rows and one column. That means, sir, you have added something, sir. That means here there is some dimension. Okay, now matrix. Matrix is basically a 2D array. Matrix is basically a 2D array of either numbers, either symbols or expressions, whatever you can say. They are arranged in row and columns format. They are arranged in a row and column format. So what you have taken above is an array that is your vectors e1, e2, e3, e4. If I do write like this, e1, e2, e3, e4, this is a matrix. Okay, matrix. And we can have multiple numbers of rows and columns in case of matrix. This is what we can have. Okay, so here, to be very simple, if I talk about your vectors, we just represent vectors like this only in a form of an array, the simple array. But here we have modified our array into two dimensions. Okay, now we have previously we are having one dimension only. As I told, either I am having just only one dimension like this, either this representation in a row major or either in a column major. So one dimension I'm having. Okay, basically here we need to arrange them in a row major only. Okay, but if we increase the dimensions, one more dimension add, so this is a 2D improved. Okay, so we are having 2D matrix. This is how you very well know about how elements are organized in a matrix. And if I want to access any element from the matrix, for example, if I do right like m1 is 0, what does this means? M10 means, see, um, row, this is your first row and this is your second row. Okay, this is your first column and this is your second column. Okay, so m10 that means your first, how you represent, how you represent, this is your 0th row and this is your 1th row. Every time every time the indexing starts from 0, whether you take your column or whether you take your row. So this is your 0th column and this is your 1th column. This is your 0th row, this is your 1th row. So if I just write like this, m10, so 1th row and 0th column, your element is e3. Okay, now many important things to understand. So let me get back to you here, from this document to the paint, because we are going to check out, uh, there are not so many operations which we need to understand related to the scalar or related to the vector, but there are many operations related to the matrices in linear algebra. In linear algebra we have studied on the basis of matrices only. We have studied on the basis of matrices only, linear algebra. Okay, vectors and matrices. Okay, so let's see, let me get back to you with the paint, and there we will perform the operation, all the matrix operations. So here is the paint. Okay, I hope it is visible to you.
Yeah. Yes.
Okay, now we need to perform various matrix operations. Okay, the first thing is, what do you understand by an identity matrix? What do you understand by identity matrix?
Diagonals are 1.
Diagonals are one. Okay, so if I just do prepare, the first one is your identity matrix. Okay, so all the diagonal elements are one in case of identity. So if I do prepare a 3 cross 3 matrix, if I write like this one, diagonal elements are one. Is this the identity? And what about the remaining elements? Either they
0.
zero. Okay, good. So 0, 0, 0. Okay, this is your identity matrix. Okay, so the first matrix is your identity matrix where diagonal elements are 0. You can prepare a 2D matrix also identity. You can prepare your 3D identity matrix also. Here I have created a 3D identity matrix. Okay, this is what I have prepared. Now if the question comes, if I need to perform multiplication of a scalar to a matrix, and if I need to perform a multiplication of a vector to a matrix, okay, what should be the result? Or either I need to perform matrix to matrix multiplication, what should be the result? Now here we need to do some maths. Let us consider some matrix. Okay, let us consider some matrix because we need to perform all these operations. So we'll take simple metrics and we revise our mathematical concepts. So let's take metrics like we are having 2, 3, 4, 5. So the first case is you need to multiply a scalar to a matrix. For example, your scalar quantity is just take it as 5. Okay, so I need to perform scalar to matrix multiplication. Scalar to matrix multiplication. What could be the result? What will be the result? The result will be a scalar or a vector or a matrix. What is the result? What do you think? What is the result here? It will be a matrix.
Matrix.
Obviously, it will be matrix.
Matrix.
So, how the multiplication here will be done? 5 into 2. Is that okay? 5 2s are 10. Then 3 5s are 15. Am I right?
Yes.
5
Yes,
4s
sir.
are 20. Okay. And 5 5s are 25. This is how when you multiply a scalar with your matrix. This is what we get the result. Okay, very simple. Okay, maths. Now the case is if you want to multiply a vector with a matrix, then how you can perform this task? Okay, let us consider a vector and then perform a multiplication of it. So what vector I am going to take? Case number 2. What vector quantity consider? So I am considering a vector quantity like this: 2 3. This is a vector. Why? Only one dimension. This is only one dimension. This is a vector. And take the same matrix to perform the operation: 2 3 4 5. Now vector to matrix multiplication. Please let me know what is the output, how you multiply a vector to the matrix. So if I just consider this 2, 2 multiply by 2, isn't it? Is it?
Yes, sir.
Yes.
2 2s are 4. Then what's next? Plus. Then what's next? What to do?
2
4.
into 4.
2
2 into 4.
with whom? With whom?
4.
2 into 4.
2 into 4. This one. Okay. So you multiply this 2 with this, plus you multiply with
So
this
it's
2.
2 into 3, right?
2
2
into
into 3.
2 into 3. Okay. 2 into 3 is saying 2 into
It's
3.
first row into first column, right? First row into first column.
Is it the case first row or the first column? Is it the case?
First row and
No, first. No, sir. It is 2 into 2 plus 2 into 4, I think.
Hmm.
Yeah.
Yeah, she's saying,
first row and
yeah,
first column.
yeah, she's saying correct. Okay.
Okay, okay.
So, you need to multiply this by this and this by this. Okay. So 2 into 2 plus 2 into 4. So 8 plus 4, your result will be 12. Now, what next? What next? Again, take 2 into 3. Is it okay?
Yes, sir.
2 into 3 plus 2 into 5.
20.
So 6 plus 10, I guess. Okay. 6 plus 10. The result will be 16. So shall I write here 16? Is that okay? Okay. Next, 3 into 2 plus 3 into 4. So 3 2s are 6 and 3 4s are 12. So it will be 18. Okay. And 3 into 3 is 9 and 3 5s are 15. So 9 plus 15, it is your 24. Because I have taken a vector quantity in a column major format. This is a column format. Okay, this is the result you are getting. Now let us have a change. Just take this same matrix like this: 2 3 2 3 multiply by 2 3 4 5. Okay, now what will be the result? Is it like
I
this?
don't
Yeah, yeah, yeah.
I
Say
don't think it can be multiplied.
it can be multiplied. Okay. Um, there is some twist behind it. Okay, what is how this has been represented? Two rows and one column. Okay, what is the dimension of this? And what is the dimension of this? If I just say the dimension of this is
2 into 2.
2 into 2, 2 into 2. This is the dimension. Okay. So then what is requirement for the multiplication? What is the requirement for the multiplication? You tell me. What is the requirement for the multiplication?
Uh, the rows need to be the same, I think, between the two
Okay, the
matrices.
number of the rows should be equal to the number of elements of the vector then only it can be multiplied. This is the condition to multiply a vector with a matrix. The number of rows of the matrix should be equal to the number of elements of the vector. Okay, here I'm not multiplying a matrix to a matrix. I'm multiplying a vector to a matrix. Okay, here I'm multiplying a vector to a matrix. So the number of rows of the matrix should be equal to the number of elements of the vector, then only it can be multiplied. So matrix multiplication is basically associative and distributive in nature, but it is not commutative in nature. Okay, it is absolutely not commutative. Okay, so if we just multiply a matrix with a vector, okay, so you got the result as shown above. But here what is the case? Now with this matrix, what is the case you are having? How many elements you are having? What is the row?
One,
One. And how many?
One.
And what about
two,
this matrix? Two.
two,
There are two rows here,
Yes.
and here we are having one. Okay,
One.
one row and two columns, isn't it? And here we are having 2 cross 2. So shall it not be multiplied? Here multiplication is possible or not? As per my definition, I told that number of rows of the
So
matrix should be equal to the number of elements. Here the number of rows in the matrix are 2, and the number of
it
elements which are present in a vector is also 2.
it is possible, sir.
It is possible, na? Okay,
Yes,
so
sir.
do the multiplication. You can do the multiplication. So 2 into 2, 2 into 2.
Oh,
So here what happened? So here, did it, any mistake has been done here? Here, how many elements are there? Here also we are having two rows in the matrix, and we are having two elements in your vector. Here also we did. I think our concept was correct to perform the operation. Okay, so two. How the multiplication here is been done? So two is a four, I guess. Okay, 4 plus 3 into 4. Am I right? Is it or is there something different? What should be the multiplication? 2 twos are 4, and and 2 twos are 4, and then what? 3 fours are 12. Is it or what? Tell me. Matrix
Yes,
multiplication.
yes. Yeah.
So 2 twos are 4 plus 3 fours are 12. So the result will be 16 something,
Yes.
and then 2 threes are 6 plus 3 fives are
3 into
15.
5.
So the result will be 21 something. Is it or not? Please tell me. Or we need to do something else.
Yeah, it's correct, sir.
It's correct. So here what
Yes.
no.
we are not been correct. We are not been correct here. Why?
So how? I mean, now we'll get okay. The dimensions only change, right? In the ultimate one. I
The
mean,
dimensions we have changed. Now we are
uh,
available with one row and two column here. The dimensions has been changed. We changed the
but our
dimension.
output is just one row and two columns
One
again.
row and two
Okay.
column. Yeah, output is just like one row and two column.
So I still feel you can't multiply it. I don't know why I'm feeling that.
You're feeling like you can't multiply.
Uh,
Hmm. Okay. You're feeling like there could not be any multiplication. Why are thinking that there cannot be any multiplication here? What could be the reason? Because as per the property, we can multiply a matrix and a vector if the number of elements of the vector and the number of rows present in the matrix should have to be equal. This is the rule.
होतो कोई चार
Okay, this is the rule.
चार होतो कोई
Okay, so what do you think? Any suggestion, or should I proceed ahead? Or still you are in a doubt? You are in some doubt.
So I think 2 multiplied by with first column
Okay,
and then
2
uh,
multiplied in the first column, then 2 multiply the
then
first column. That means 2 twos are 4, and 2 fours are 8. This is what you are saying. And then
yeah.
okay, let's see. No, that is why you are here to learn the linear algebra, and this is how the mathematical foundation needs to be done. Okay, so you are saying that, sir, there will be some different results also, like this. 2 should be multiplied to 2 also and 4 also. So what kind of operation I need to add them? I need to add them. 2 twos are 4,
Um,
or and then 2 fours are 8. Is that what I need to do? So what will be difference between here and here, what you are doing? Is there will be any difference? Because I've changed my vector. I did change my vector. Okay, so you need to take care of that particular thing. You need to take care of that.
so rule with like a matrix rule is that
Hmm.
with like number of column and in both the cases like it should be two,
Hmm. It,
like 1 into 2,
huh.
and here also 2 into 2.
Okay.
So the number of column in the first matrix and the number of column in the second matrix should be same.
Okay. Okay.
This is, I know, I maybe I will wrong also.
Okay. See what happens here. Let me take you one more example and put this thing. For example, if you are having a matrix, let me take one more example and clear it in a much more better way. For example, you are having 1, 2, 3. This is your vector. For example, this is your vector. Okay, and if you are having a matrix like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then the multiplication which needs to be done or required is 1 multiply by 1. So 1 plus 2 multiply by 2, 4 plus 3 multiply by 3, 9. Okay, this is the result. Then 1 multiply by 4 plus 2 multiply by 5, that is 10. Oh, yeah. Okay, 10. Then 3 multiply by 6, that is 18. So the result will be 28 plus 32. And then again 1 multiply by 7 plus 2 multiply by 8, that is 16, and 3 multiply by 9, that is 27. That is 27. Okay, so this is how vector and matrix multiplication has been done. This is how a vector and a matrix multiplication be done. What you did here? What kind of multiplication you did here? You multiply 2 with 2. Okay, and then what you did? Then you done addition plus. You did addition plus 3 multiplied by 4.
4, yeah.
Okay, this is what and you told sir result is like okay, 12. This is what you did. Moreover, here you did a kind of a matrix to matrix multiplication. This is what you did. This is what you did here. Matrix to multi a kind of a, what happens in a vector to matrix multiplication. This is how you need to perform. This is the exact kind of work which you need to do in case of your matrix to matrix multiplication. This is what you need to take care of. Okay, in matrix to matrix multiplication, this is what you need to take care. So this is the correct multiplication which I have done. So in this lecture I was just listening to you guys, and okay, this is how the multiply, just revising the concept. Okay, what you remember, okay, how to multiplication needs to be done and what should be the idea. So this is your vector. Now any suggestion from your side, any discussion I want to get from your side?
So can you just
Yeah,
show an example wherein you cannot multiply?
see, this is your correct share. Correct vector to matrix multiplication.
Mm-hmm.
Okay, this is absolutely correct. And whatever you did here, you are more over to your matrix to matrix multiplication. This is what you have considered here. Okay, but this operation which you have done here, this is vector and this is your matrix. Okay, and this is how you perform. So 1 to 1 plus
Plus
2
2.
to 2 plus 3 to 3. This is how you need to multiply. Okay, so here, as I told, I was repeating every time, the number of elements in the vectors should be equal to the number of rows in your matrix. In case what will happen, in case what will happen, if your what if the number of rows of the matrix is not equal to the number of elements of the vectors, then as per the property I told, associative, distributive, and commutative. What is associative property? A plus B plus C. Here I just take a multiplication. A into B equal to B into A. That is associative. What is distributive property? A into B plus C. That means A into B plus A into C. That is distributive. And what is commutative? A into B equal to B into A. Okay, so here the vector matrix multiplication is distributive also, associative also, but it is not commutative. So let me get back again and explain. Here you have taken vector first and matrix. Okay, next, if you take matrix first and vector, then if you take matrix first and vector, then okay, just make erase everything. I need to learn a lot to do work upon paint, because here it will be definitely required. Okay, either I will be use some brush. I use brush, and then is that no? Your rubber will be, because when I was teaching on an academy, they are having their own tool, and everything get erased, or they are having their paintbrush. They are good option, but here I need to use this, which is available. Okay, anyways, so let me change. I multiplied a vector with matrix. Now if I just do take matrix first and then the vector, so 1 2 3 4 5 6 7 8 9, and then just take 1 2 3. This is how I need to do vector to matrix multiplication. So this is not commutative in nature. You're not going to get the same result like this. You're not going to get the same. Okay, your result will be not as same which has been expected. What could be the point? What result you are getting here? What do you think? What result you are getting here? What has been achieved? What result should have to be there? I need to take one. I'll take one. Here also I did take 1 multiply by 1, then 2 by 2, and 3 by 3. This is what I took. Okay, so I take 1 multiply by what I will take? 1, isn't
1.
it? 1 multiply by 1. Okay. Yes. 1 multiply by 1. Okay. So 1 multiply by 1, the result will be like 1. Okay, 1 multiply by 1, result will be 1. Then 4 multiply by whom? There is no option available. 4 multiply by whom? This one. Because if I am not available with something here, so whom should I multiply? Then next what will happen? 7. Whom? What should I do? Then the next case is 2. If I just take 2. So 2 multiply by 1. 2 multiply by 1. It will be 2. Is that okay? Is that okay now? Okay, only 2. I'm not available with any other things. Okay, to multiply this complete with any other 1 by 1 element present here. No. Then if I just take 3, 3 multiply by 1, this is 3. 1 2 3. What next? I do take 4. 4 4. Okay, if I just take like this 4, am I going right or not? Am I going right or not? Because previously you are taking this value then you are taking this value, then you are taking this value. So I should have taken what? I should have taken like this. What? I took 1 into 1, then 2 into 2, and 3 into 3. So I should have taken like this: 1 into 1. That's it. My point is over. And then what about these two? What these two row? Okay, so definitely twist आ गया यहाँ पे. ये तो लग ही नहीं रहा है सर, ये कैसे मल्टीप्लाई होगा? ये कैसे मल्टीप्लाई होगा? जैसा अप्रोच विच व्हाट आई हैव टोल्ड यू, इफ यू आर बीन वेक्टर अवेलेबल हियर एंड इफ यू नीड टू मल्टीप्लाई विद योर मैट्रिक्स, ओके, सो दिस इज हाउ यू विल गेट द रिजल्ट. अभी कैसे यहाँ पर परफॉर्म होने वाला है? ओके, तो यही लीनियर अलजेब्रा का खास रोल है यहाँ पर प्ले करेंगे जब हम वे टेक द डायमेंशंस, डिफरेंट डिफरेंट डायमेंशंस एंड वे डू परफॉर्म द मल्टीप्लिकेशंस. तो यही खास हो मैट्रिक्स, क्योंकि व्हेन यू आर नाउ टेकिंग हायर डायमेंशंस, तो उस केस के अंदर इफ यू आर वर्किंग विद हायर डायमेंशंस, तो वहाँ पर क्या होने वाला है, ये आपका प्रॉपर्टीज सारी आएंगी. ओके, एसोसिएटिव, कम्यूटेटिव, डिस्ट्रीब्यूटिव सारी प्रॉपर्टी, और फिर आपको ये टास्क परफॉर्म करना है, एडिशन, मल्टीप्लिकेशन. ये ही लीनियर अलजेब्रा के अंदर पूरा की पूरा आना है. ओके, दिस इज व्हाट यू नीड टू गेट. ओके, अभी अभी ये नहीं हुआ है, अभी खत्म नहीं हुआ है. लेट अस टेक, मैं अभी और एग्जांपल ले रहा हूँ. ओके, लेट मी टेक सम अदर मोर एग्जांपल्स. जैसे कि मान लीजिए मैंने मैट्रिक्स लिया, आई डिड टुक अ मैट्रिक्स लाइक फॉर एग्जांपल आई टेक, जस्ट प्रिपेयर अ मैट्रिक्स. इसको मैं फिर से रब कर रहा हूँ, रबिंग दिस. Okay, this will be quite hectic.
You can take a new one, I think.
A new slide. Now it is visible. New slide is visible to you?
Yes, sir.
Okay, fine. So let us take a matrix M equal to, just take like 1 2 1 2 3 4 and 5 6. Just take a matrix like this. This is a new matrix. Okay, and the vector which you can take is just consider like 1 and 2. Just take n equal to 1 and 2. Take this as a vector, and I need to perform the multiplication of them, that is your m into n. This is what I need to perform, m into n. I need to perform over it, m into n. Now sorry, m into n, like this. I need to perform this operation. Now what will be your result here, m into n? If I need to perform here m into n, what will be the results? What will the results? 1 into 1, and let me write side by side. 1 2 3 4 5 6, and here it is like 1 1 2. So results: 1 into 1 plus 2 into 2. So result will be 5. Okay, then 3 into 1 plus 4 into 2. So 3 into 1 is 3, plus 4 2s are 8, so it will be 11. Then 5 into 1 plus 6 into 2. Okay, so how you are multiplying the elements here? Just one by one, 5 to 1, then 6 to 2. So 5 ones are 5 and 6 twos are 12. So result will be 17. Your result, so this is your result. This is your final result. 5, 11, and 17. This is your result. Okay. Now this, if this is the result, let me flip 1 2 1 2 and 1 2 3 4 5, 6. Tell me the result. What should be the result? It will like 1 into 1. Is that be the thing? And 2 into 3. Is that be the thing? What should be the result? Am I going correct? Or it should be like 1 into 1 and 2 into 2.
Cannot be multiplied.
It cannot be multiplied. Yeah. What could be the reason why it cannot be multiplied?
A number of
Because the vector size is not equal to the number of rows.
Okay, vector size.
The vector is not equal to the number of rows of the matrix.
But here what happened? Here also isn't it the same situation here? Here.
No, no.
No.
number of column in the first matrix
Hmm.
should be equal to the number of rows in the second matrix.
Okay, so here the size was like this 3 cross 2, isn't it? And here the size is 2 cross 1. So because of this, you perform the multiplication. Okay, now what happened here? Here the size is 2 cross 1
1
and
3 cross 2.
3 cross 2. So here इच्छू हो गया, गड़बड़ हो गई ये गड़बड़ हो गया. ओके, तो ये मल्टीप्लिकेशन नहीं हो पा रहा था, तो कम्यूटेटिव नहीं है ये. दिस इज नॉट कम्यूटेटिव इन नेचर. ओके, इस ये इसके अंदर वी फाउंड इट. ओके, सो ये मल्टीप्लिकेशन नहीं हो पाएगा. ओके, सो वी डिड डिस्कस्ड अबाउट स्केलर. तो काफ़ी इजी था, और आप जहाँ फंसे, जो ट्विस्ट हुआ, दैट इज रिलेटेड टू योर वेक्टर टू मैट्रिक्स मल्टीप्लिकेशन. अब अगला तो ये है कि मैट्रिक्स टू मैट्रिक्स मल्टीप्लिकेशन. चलो अभी नहीं छोड़ रहा, मज़ा नहीं आ रहा, अभी ऐसे नहीं छोड़ूंगा आप लोगों को. चलो न्यू, डोंट से मैट्रिक्स टू मैट्रिक्स. चलो आ जाओ. 1 2 3 4 एंड 5 6 7 8. ये मल्टीप्लिकेशन इज देयर एनी पॉसिबिलिटी मल्टीप्लाई हो जाएगा?
Yes, sir.
Yes, it
ये
can.
2 क्रॉस 2 है और ये भी 2 क्रॉस 2 है ना, हो जाएगा. ओके, 5 6 ऐसा लें तो अब होगा मल्टीप्लाई. ये कितना होगा? 3 2, और ये कितना है?
होगा.
तब भी हो जाएगा.
It will happen.
ओके,
Yes, sir.
चलो ठीक है, करते हैं ना. तो क्या प्रॉपर्टी क्या बोलती है? 3 क्रॉस 2 है ये, और ये 2 क्रॉस 2 है ना, 2 क्रॉस 2. तो जहाँ तक मुझे पता है कि ये जो दोनों हैं ये सेम होना चाहिए, isn't it? तो जाके मल्टीप्लिकेशन हो
Yes.
सकता है. आई होप इफ वी हैव स्टडीड एज पर द मैथ्स. तो ये दोनों सेम होना चाहिए, तो मल्टीप्लिकेशन हो जाएगा. सो हाउ टू मल्टीप्लाई? 1 into 5 plus
2 into 7.
2 into 7, isn't it? So 1 5 are 5, 2 7 are 14, so 19. Okay, next क्या है? 1 into 6, is it? And 2 into 8. सही बोल रहा हूँ? Am I right or not? मुझे बताते जाइए. 1 into
Yes.
6 and 2 into 8.
Yes.
So 6 plus 8 into 16. तो कितना हो जाएगा? 22. ये आपका पहला हो गया. Now 3 into 5 and 4 into ये क्या 7 है ना? 3 5 are 15 and 4 7 are 28. तो 15 plus 28, how much it is? 43. चलो ठीक है, लिख लेते हैं 43. फिर 3 into 6 and 4 into 8, 32, and 6 3s are 18. So it will be like 50, for example. ठीक है, ऐसा कर लें 50, and so on. 5 5s are 25, and 6 7s are 42, 25, and 42. 42 and 25, how much it is? 67. Okay, then 5 6 are 30, and 6 8 are 48. So 78 हो जाएगा. ये सही है, रिजल्ट आ गया. एंड व्हाट मैट्रिक्स रिजल्ट यू गॉट? दैट विल बी
3 cross 2.
3 क्रॉस 2. 3 क्रॉस 2. ये जो था ना, ये वाला 3 क्रॉस 2, ये आ गया यहाँ पर रिजल्ट. ये मैट्रिक्स मल्टीप्लिकेशन है. दिस इज द रिजल्ट व्हिच यू हैव गॉट. अब यदि ये प्रॉपर्टी फॉलो हो रहा है तो मैट्रिक्स मल्टीप्लिकेशन होगा. ओके, एल्स आपका मैट्रिक्स मल्टीप्लिकेशन नहीं होगा. ठीक है.
Okay, sir.
ओके.
Okay, sir.
Okay, so we will check out other further concepts in a linear algebra. So what? Let me stop the recording.